Hi, Dr. Wang here. In this video, we're going to continue the discussion on FOA data analysis. This is related to the assignment lab 9.2. So over here, we have the yeast growth pattern on SD plate and also on FOA plate. So if you remember from the protocol, the same amount of yeast are basically plated on SD plate and on FOA plate. So how do we explain the difference in growth pattern? We have this concept map basically summarizing the genotype of the yeast plated on FOA plate. I'm going to use SP0 as an example. So this yeast doesn't carry functional MSH2, so the mutation rate in this yeast is fairly high. When we plate millions and billions of yeast on the plate, due to the mutation rate, there will be a small portion of the yeast that contains mutations. So basically mutations that disrupted the GT16.5, causing frameshift mutation, and the URA3 gene is not supposed to work. But this is only a small portion of the entire yeast population. The majority of the yeast will still contain the functional URA3 gene. When we look at the growth pattern of these two types of yeasts on SD plate without histidine, tryptophan, and uracil, we can see that all yeast should carry the functional His3 gene, functional TRP1 gene. For the URA3 gene, the mutated yeast doesn't carry functional URA3 gene, so they're going to be starved to death in absence of uracil. This is an essential nutrient. However, the majority of the yeast should still contain functional URA3, so they should be growing just fine. And this is what we see on the SD plate. Over here, most of the yeast cells plated are growing, and we can't really see any difference among different strains. It's just because this area has been saturated with a large number of yeast cells. Now, coming back to the FOA plate. In FOA plate, when URA3 gene is mutated, then it cannot convert FOA to toxin. Right? So without URA3, this is not going to occur. So we do have growth, and this media has uracil, so the yeast is not going to be starved to death. When we look at the majority of the yeast that contain functional URA3, we can see here that since URA3 gene is working, it's going to produce toxin to kill the yeast. So the yeast over here is poison. On FOA plate, the majority of the yeasts will be killed, and then a small portion will be able to grow. So this is what we see on FOA plate. We only see a small percentage of the entire yeast population are growing on FOA plate. And then over here, because the number is so small, the area is not saturated by yeast cells, and then here is where we can start to see difference between different strains of yeast. So for example, SP1, this is the mutation rate is low, right? This is the wild type MSH2, so therefore we don't really see much growth here. And for SP0, since the overall mutation rate is high, we're going to see more of the mutated yeast growing on the FOA plate. We can also think about another type of media. So on this media, there is no FOA, and however, uracil is also provided. So here, both types of yeast are going to be fine. So for the mutated yeast, it's going to be fine because uracil is provided in the media. For the yeast that haven't mutated yet, it's going to be fine as well because there is no FOA that's going to be converted to kill the yeast. So both type of yeast should be fine under this condition.